Hello, adult learners. Welcome back. We're going to dive right into our next lesson here. This is the last lesson in section E of the math course. E is the first level. There's 4 lessons in it. This is the 4th one. We're going to bust this out tonight. These notes that I'm looking at and I'm drawing on here on my screen, I'm posting a blank copy of it on Google Classroom for you. So if you would like to print this out at home and write your notes that way, that's great. If you don't have a printer or you prefer to just like make your own notes, which I know I used to always do when I was in school, you could just grab some blank paper and start filling it out, and let's get started. So we're talking about geometry tonight. Geometry is when we are studying shapes and angles and measures of those things. We're talking about perimeter and area and volume and surface area and just all these crazy things, all these formulas. And when we really dive deep into geometry later, we'll talk about angles of triangles and proving measures of angles and theorems about geometry and just all kinds of crazy stuff. But you can't get there unless you've got a good foundation. So that's what we're starting with today. This is all about geometric shapes. So the first thing we have are some regular 2-dimensional shapes. And I'm going to clarify for you in just a minute what I mean when I say regular, okay? Because that is there for a reason. Okay, I'm not just calling it regular because I feel like it. There's a definition of what it means for a shape to be a regular shape and an irregular shape, okay? So some regular 2D shapes or 2-dimensional shapes that you can see here are like squares, rectangles, circles, ovals, triangles, pentagons, hexagons, octagons. If you notice something about pentagon and above, like they end in G-O-N, you can't really see that now because it cut off for some reason, but it's pentagon, G-O-N, hexagon, G-O-N, octagon, G-O-N. And so that is actually like how we classify shapes. They are, every shape is a polygon, okay? But some shapes just have like a more well-known name to it. If it ends in the word in the letters G-O-N, then that means that the first part of the word is describing to you how many sides the shape has, and we're going to talk about that in a minute. You can also have 3-dimensional shapes, so cubes, cylinders, spheres, cones, prisms, pyramids. These are 3-dimensional shapes, which means they have a length, a width, and a height. They have 3 different dimensions that you measure them by. 3-dimensional objects are most closely modeled in real life by the objects that you or I can pick up and touch and hold in our hands. So like this pencil I'm drawing with, my calculator, these are 3-dimensional objects. They take up space, okay? And they're different from 2D shapes. They have a foundation in 2-dimensional shapes, but they are not the same. 2-dimensional shapes only have 2 dimensions, that is length and width, and they take up flat space, but they don't take up 3-dimensional physical volume type of space. Okay, so regular versus irregular. Remember I said I was gonna kind of go through what I mean by that, okay? Like when I say that something is regular, I mean that it is a regular shape when all the sides and the angles are the same size. So for example, let's pick something that's good. Okay, how about a triangle, right? So regular versus irregular. A regular triangle might look like this. That's a really bad drawing, but you get the idea. The 3 sides are about the same length, and then the angles that are inside, so this angle, and this angle are going to measure the same. That's a regular triangle. An irregular triangle might look something like, I'll switch colors, let's do like red. An irregular triangle might be something that has like like one of these, and then this is really long, so those are not the same size, and then you might have this connecting line here. It's still a triangle because it has this angle, and this angle, and that's where that word comes from, is triangle. There's 3 angles. But it's not a regular triangle because these angles are not going to be the same measurement and the sides are not the same measurement. And that can be applied to any of these 2-dimensional figures that you see right here, okay? So let's talk about what we mean by, remember I said that the prefix of any word that ends in G-O-N, gone, any word that ends in gone, is a polygon, but the prefix tells you how many sides that shape has. Poly just means multiple or many. So when I say it's a polygon, you have no idea how many sides that is because I wasn't specific enough with you with my language, right? Polygon just means that it has many sides. Poly means many. So if a shape has 5 or more sides, you have to use more specific terminology to explain to somebody what type of shape it is, how many sides it has. So this is like a chart that you can look at. So if it's 3 sides, it's a triangle. We don't call that a trigon. I guess you could call it a trigon or a threegon. I wouldn't. It's just not. You'd call it a triangle. A 4-sided shape is a quadrilateral. We're going to talk about what that means on the next page, so don't read too much into that right now. 5 and above. So if it's a pentagon, so penta means 5, and gon describes that it's a shape with sides. So this has 5 sides. A hexagon, the hexa part means 6. Heptagon, hepta means 7. Octagon, a stop sign is an octagon. It has 8 sides. Octagon, octa means 8. Enneagon, that means 9. And then decagon, that means 10. And it goes on and on. There's more. We're gonna not really go into all the other prefixes that you could possibly see in the the scope of what this lesson is about. But if you're really curious about it, and that's cool if you are, there's a link you can follow right here, and this link will give you a listing of all the different prefixes that you could possibly have and how you actually can combine those, because you can have shapes that have like 300 sides. I mean, it's totally possible. It would probably be hard to see all those sides with the naked eye. Like, how would you draw? You know what I'm saying? Like, this is probably the most I can get down drawing them, but anyway, they exist. But anyway, so that's how polygons work. That's what the prefix of those words mean. Okay. So we're gonna roll down here and we're gonna talk a little bit about quadrilaterals. So quadrilaterals, all right. Quad, the prefix quad, Q-U-A-D, right here. Quad means 4, and the word lateral means side. So literally the word quadrilateral means a shape that has 4 sides. There are so many different kinds of quadrilaterals that are more specific, and we're going to kind of discuss like how you would tell the differences between them all. But all of the shapes I'm about to show you are quadrilaterals. They're just special quadrilaterals. So let's roll down here. This big box that we have here. All right, I'm going to try and fit that on the screen just right. This big box that we have here. My cat is crawling up my chair right now. I can feel her crawling here. Hi Juno. Say hi to everybody. No, she doesn't want to say hi. So that's Juno. Anyway, so quadrilaterals, right? All of these shapes that you see here are quadrilaterals because they have 4 sides. That's all. That's the bare minimum that you have to be a quadrilateral. This one that's hanging out all by itself over here on the side is an irregular quadrilateral, or you could just call it a quadrilateral. I mean, either way. But there's nothing special about this. It's something that has 4 sides. A parallelogram is when you have the 2 sides and then the 2, we call them bases. That's the top part and the bottom part. If the 2 sides are parallel and the 2 top pieces are parallel, that's a parallelogram. Now notice I didn't say anything about the lengths of the sides. I'm only talking about them being parallel. Parallel just means that they are directly across from each other, okay? And that the two lines are never going to like intersect or cross each other. If you look at this parallelogram right here, the top and the bottom right here, they're just like straight lines, right? And they're parallel to each other. And then if you look at the sides, yeah, they're slanted a little, whatever, but they're parallel to each other. That's a parallelogram, okay? It's a quadrilateral where the top and the bottom are parallel and the left and the right sides are parallel to each other, okay? Inside of parallelogram, so this big circle here, this encompasses all these shapes, all right? There's special kinds of parallelograms. You have a rectangle, which is a parallelogram, because the top and the bottom pieces are parallel, and the two side pieces are also parallel to each other. But what's special about a rectangle is that the top and the bottom pieces, the bases, they have the same measurement as each other. And then the rectangle, the sides of that rectangle have the same measurement as each other. So something we can use to sort of like separate all these is we're going to use some symbols, right? So parallel lines typically have like a dash through them, and that's how you can tell that something is parallel. If I have that marking on a line or a shape, that means those things are parallel. Then these two things are also parallel, but I'm using two lines instead of one line because I already used one line to describe the top and the bottom. If I put one line on the side, then I would be implying that all these lines are parallel to each other, and they're not. Okay? In the rectangle, these are parallel, and these two are parallel to each other. And also, this side and this side are the same. We'll just call it X, okay? We don't know what the measurement is, but we'll just use X, like the letter X as a variable to signify that. And then the top part we'll call Y, and the bottom part, that base, is the same distance also. It's Y, okay? So we're getting into measurements now. So we've covered two different things to look at. One is parallel, and the other is measurements, okay? Let's talk about the square. The square, these are parallel to each other, and the sides are parallel to each other. But the cool thing about the square is that all four of the sides of that quadrilateral parallelogram, okay, are the same measurement. So this is X, this measures X, this measures X, and this measures X. They are all the same. The sides and the top and bottom, they all have the same measurement. Okay, and then finally you have what's called a rhombus, okay? A rhombus is like a diamond shape. That's really all that it is. And in a rhombus, you have these two are parallel and these two are parallel, okay? And what's happening with the shapes of the rhombus is that the sides, all the sides are the same. So we'll call this like X, 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 and X. But there's like a little more to this, because you might be wondering right now, like, what would be the difference between like a rhombus and a square then, right? There are more differences. I don't want to dive too deep into why they're different right in this lesson, because we're not really at that level yet. But they are different. There's things called diagonal shapes, so like a diagonal line that goes across from the angles that make a rhombus different than like say a square. Okay, so that is all parallelograms, right? A rectangle, a square, and a rhombus, they are parallelograms and they are quadrilaterals, okay? Now, there's another way to sort of explain these properties, and that is to say that, well, if you're talking about like things being mutually exclusive of each other. So every square is a quadrilateral. That statement is true, right? Because a square has four sides, and to be a quadrilateral, you just have to have four sides. That's the only criteria, right? So me saying every square is a quadrilateral is a true statement. I could also say every square is a parallelogram, right? parallelograms are quadrilaterals. They have four sides. And then the two opposite sides on the top and bottom are parallel. And then the two opposite sides on the left and right are parallel. And the same is true for squares, right? So a square is a parallelogram. Okay, and that's true. That's the only criteria, right? It has to have four sides, and it has to have, two pairs of parallel sides. But what if I went the opposite direction? What if I said the statement to you that every quadrilateral is a parallelogram? Is that true or is it false? And the answer to that question would be it's false. Not every quadrilateral is a parallelogram, right? If you take this irregular quadrilateral as an example, right? This is a shape that has four sides, but these are not parallel to each other. These sides are not parallel. So this can't be a parallelogram. And therefore, not every quadrilateral is a parallelogram, okay? The deeper that you follow this tree down here, the more and more criteria that you have in order for something to be considered that shape. And that's sort of something that you'll run into a lot when we talk about geometry is like proving that, certain shapes are a trapezoid, or they are a triangle, or they are a rectangle because of certain properties that those shapes have. We also have something called a trapezoid. A trapezoid is not a parallelogram because while the top and the bottom, these bases, are parallel to each other, the two sides, they are not. They are not parallel because eventually, if you were to continue this shape and you were to continue this side, boom, they intersect with each other, right? And parallel lines never touch. They never intersect. So I'm actually just going to take that off because I don't want it to be too confusing. Let's get rid of that. Okay. The cool thing about a trapezoid is that it's going to have something called a height, and that's how you measure from the top base to the bottom base. It forms a 90-degree angle or a right angle with that base and the bottom, and you use that height to find, well, I'm getting ahead of myself, but you use that height to find the area of the shape. But anyway, it does not fall under the category of parallelogram because you don't have two pairs of parallel lines as those sides of that shape. You only have one set of parallel lines. But it still is a quadrilateral. It belongs in this box here because it has four sides, okay? All right, so that's all that there is about shapes in this topic. We're gonna move right into our next piece, which is about perimeter. So the perimeter is it's a one-dimensional measurement of a two-dimensional figure. Remember 2D shapes or 2D figures, two-dimensional, they're flat. They don't take up any space in terms of like volume, in terms of physical space that I can hold in my hand that are tangible. A two-dimensional figure is just a flat shape, but it has a length and a width, and therefore you can measure the space that is around all the sides and get a measurement called the perimeter. So a cute way that you can kind of like think of how perimeter works is you can think about like, a security guard or a cop, like if you're on a TV show or something, and you might hear them say like, oh, the security guard was checking the perimeter. He was doing a perimeter check. What that means is that like whatever property they're on, building or house or whatever, the guard is literally like walking around all the edges of the property to check the perimeter. He's checking all the space around the outside. And if he were to measure the distance that he walked, he would find the perimeter of the building or the house or whatever it is. So all that you do to find the perimeter is you add up all the sides. And then don't forget to put whatever units that's in. So like if you're measuring it in inches or centimeters or something, when you add up those measurements, you want to make sure you use the correct units. Okay, so let's do some examples. We're going to go to this next page here where we have this called perimeter practice. And all the shapes that you see here, they have all the side measurements already? Yeah, they do. I'm going to zoom out a little just so you can see everything. I'll also use like a corresponding color of my pen to match the color of the shape. So let's look at the red shape first. There's no units here. It's just numbers. So we don't have to worry about like centimeters or inches or whatever. It's just whatever the answer is, it's going to be in something called units. That's it. So add up all the sides here and you get 12 plus 1 plus 12 plus 1. 12 and 12 is 24 and 1 and 1 is 2. So that would give me a perimeter of 26. Okay, so for the red shape, we have 12 plus 12 plus 1 plus 1, and that gives me 26. Okay, let's use green for the green shape, and we have 3, 4, 3, and 4. So the green shape is going to just be 3 plus 4 plus 3 plus 4, and that gives me 14. I know that because 3 and 4 is 7, and I'm doing that twice. So this is probably a good spot for you to go ahead and pause the video. Pause the video and try out the yellow and the pink and the purple shape and just see if you can get the perimeter correctly. We're just adding all the sides around the outside, and that gives us the perimeter. Okay, so let's go ahead and do this. The orange shape or the yellow shape, whatever color it is going to be 6 and 6 is 12, and then 2 would be 14, and 2 again would be 16, so the perimeter would be 16. And then I have a purple color, 5 and 4 and 3 will give me 7 plus 5, which is 12, so the perimeter of this shape is 12. And then last but not least, and I don't think I have a pink that's going to look correct here, whatever, it's fine. Yeah, you could read that, right? The perimeter of the pink shape is going to be 4 plus 3 is 7, 8, 9, 10, 11, 12, 13, 14, and 14 and 6 is 20. So the perimeter of the pink shape is 2, 0, which is 20. Okay, so here are some shortcuts that you can follow for finding the perimeter of a polygon. When you have a triangle or some other shape that doesn't follow this conventional logic here, you would just add the sides. So like that's what this example is right here. It's just a plus b plus c, which we just did. And then you also can have like a special case where you have a square. So if you remember, when we talked about the square just a few minutes ago, we said that squares have the same measurement on all 4 sides. So all 4 are the same. So if a square has 4 sides and the sides are all the same measurement, we can just take 4 times whatever the measurement of the sides are, and that multiplication will give us the perimeter without us having to go and count all 4 sides and add them up. We're going to use that example right here in blue, and then we'll do the rectangle in just a minute. So I know this is a square because like normally a really good geometry problem will tell you that they're all the same, they're all congruent, and that means that they have the same measurement. This one doesn't, but if the base here is 5 and the width here is 5, this side is 5, it's most likely that the other 2 are also 5, and we're going to assume that they are. It looks like a square, right? So 5 and 5 and 5 and 5, if you add them together, would give me 20, right? But another way to do that would just be 4 times 5, which is 20. Okay, so that's the multiplication shortcut for perimeter of a square. All right, we also have the rectangle. Let's use, I guess, red for this. So we will red this example right here. In a rectangle, remember the top and bottom part have the same measurement, and then the 2 sides have the same measurement. So if we take twice the top and bottom and twice the 2 left and right sides, then that's a multiplication shortcut that we can use to find the perimeter. The perimeter of a rectangle is 2 times the length, that's the long ways, plus 2 times the width, that's like the height, the side, okay? So this is a rectangle, it's a quadrilateral, and For the purposes of this example, we're going to assume it's a rectangle. This would also be 7, and this would be 4. You can add them all up if you want to, but the shortcut says that you're supposed to just do 2 times 7 plus 2 times 4. And that shortcut would give us 14 plus 8. I'm running out of space. No. And that would give me 22 as my total perimeter for this shape right here. Okay, this type of problem says you're finding a missing side given that you know what the perimeter is already. So this is a different type of problem. So you already know the total measurement of all the sides. In this example, it's 31 because they said the perimeter was 31, right? So if the perimeter is adding all the sides, then this equation, we can plug some stuff in here and plug in and find the thing that we don't know, right? So the perimeter is 31. That's the total. Normally, we would be solving for that number, but we know what it is already. And then we have a question mark for this one side that's missing up here, plus we have 6 feet. That's this one. Another 6 feet. That's this one. Plus 3 feet is this one. Plus 6 feet again is this one. And then plus 6 feet again is this one. So 6 and 6 and 3 and 6 and 6 and something add up to make 31. And what we're solving for is the question mark, which is the missing side length. So let's find it, right? So 31 equals question mark plus, we can simplify this problem or make it easier for us to solve by adding all of these sides together to make it into just one number. 6 and 6 is 12, plus 3 is 15, plus another 6 would give me 21, and then plus another 6 would give me 27. So we have 31 is given by, it's equal to 27 plus something. So if you have 27, how much more do you need to go to get to 31? That's what this question is asking. So that would be 3 and 1 would give me 4. So the missing side length is 4. I'm putting feet, and there's a reason why I'm putting that. All the other lengths of these sides here are in feet, so we also need to put our answer in feet. So the missing side is 4 feet. That is the answer to this question. Okay? Now we're going to move on to the last topic in this section, which is about area of triangles and certain quadrilaterals, okay? So we're going to talk about a parallelogram, we're going to talk about a triangle, and we're going to talk about a trapezoid, okay? And when I'm talking about the area, is remember that when we're talking about two-dimensional shapes, we're talking about the fact that they are flat and they take up a certain amount of space. Well, just measuring the perimeter of that, it doesn't really tell me how much space is covered. For example, you have my screen right here, right? Okay. If I took a piece of paper, which I have handy. Here we go. Yeah. Here, I got it. I'm gonna use my my debit card. Okay, cool. Because I'm just improvising. You have my screen here, right? And if I ask you a question of how much space does my debit card take up? First of all, what shape is this? It's a rectangle, right? I mean, for all intents and purposes, it's a rectangle. The two sides over here are, I don't know why it's moving right now. That's very weird. Okay, it's still moving. Okay, it's totally creepy. I'm not crazy though, because you guys can see the video and you can see that my card is moving. My hands are in my air right here. I am not touching it. Super creepy. There must be a ghost in here, whatever. So these two sides are parallel and these two sides are parallel, and they appear to be different lengths. Like this side is shorter than this longer side. So that would give me a rectangle. So in order for me to find out how much space this is taking up of my monitor that you can see here, I would want to take the area, meaning all the units that are inside of this shape, okay? Let me get my debit card off the screen because that's freaking me out. there's an easy way, a shortcut, in order for you to find the area of basically any shape. You'll usually have an area formula that you can follow that goes with that type of shape. In this case, we have a parallelogram as our first thing. And the area of that parallelogram can be found by taking the base times the height. That's what this formula is right here. And that includes squares and rectangles. Whatever the shape is, if it's a parallelogram, 4 sides, 2 pairs of parallel sides, okay, that's a parallelogram. You can find the area of that parallelogram. You can find how much space is inside here, all the stuff that I'm coloring in right now. You can find how much space that is by multiplying the base times the height. Okay, let's do that. Let's stay on the parallelogram thing and do that example first. That's this first one. The top and bottom sides is the same. The left and right sides is the same. That makes this 7 centimeters as well. And that makes this top part 15 centimeters. We have all the measurements we need. You need to know what's a base and what is a height. The height of a parallelogram is the distance. Ooh, wow. I don't know why that zoomed so much. The height is this perpendicular line that goes from the top base to the bottom base and makes a 90-degree angle down here at the bottom. Don't worry so much if you have not learned before what like a 90-degree angle is or what perpendicular means. It's fine. That's not what you're being tested on. You're being tested on knowing what these different pieces are, meaning the height and the bases. So we have a base here, a base here. The height is in between them. This is the height. And in order for you to find the area of this, you are just going to take the base, meaning the area, is the base 15 centimeters times the height, which is 5 centimeters. Okay, so 15 times 5 is how much? Well, 5 times 10 is 50, and 5 times 5 is 25. So 50 and 25 makes 75. And that would be centimeters squared. Okay. Whenever you are talking about the area of something, okay, that is a 2-dimensional measurement of something, of a shape, okay? And so anytime you're talking about the area, you have to make sure that you express that using this notation here, which is the exponent of 2, which indicates that this measurement is based on 2 dimensions, which is the length and the width, or the base and the height, or whatever you want to call it. So make sure that you're putting that in whenever you have an area problem. It's going to be whatever the units are and then squared. This is the area of this parallelogram is 75 centimeters squared. Okay? All right, the next piece we're going to talk about is triangles. Let's switch colors. We're going to use blue to talk about triangles. The formula for an area of a triangle is very, very close to the formula of a parallelogram. It's still the base times the height, but that's also being multiplied by 1/2. So whatever the base and the height come out to be, you just cut that in 2, and that is the area of your triangle. So let's look at 2 different types of triangles here. This first triangle, the base is the bottom piece, and the height is already given as this side angle because it makes that right angle or 90-degree angle with the base. So the area will be 1/2 times the base, centimeters, times the height, centimeters. Okay, so 4 times 3 is 12, so this is 1/2 times 12 centimeters squared. And then half of 12 is 6. 12 divided by 2 is 6. So this is going to be 6 centimeters squared. That's the area of this triangle, okay? Now, over to the right here, you actually have a very large triangle, okay? So there's 2 ways you can approach this, right? If I cover up this side here, right, that's a triangle, isn't it? And then if I cover up this side, what's left is another triangle. So if you take the area of both those triangles and then you add them together, you'll have the area of this entire triangle, right? Because the big shape here, actually, I'll trace it, right? So this big shape is a triangle because it has 3 sides. But then if I switch colors to make it a little more obvious, this shape is a triangle, and I'll use orange for this. This shape is also a triangle, and the two of them mushed together form this very large triangle. So there's 2 ways to look at this problem, right? The first is that you cannot find the area of the triangle, the big triangle, because you don't know what the full base is. Right now, you only have the base over here, which is 5 inches, okay? So in this question, you actually have to do it the way I mentioned, which was doing both the triangles separately and then adding them. So let's do that. The first triangle here will be 1/2 of the base times the height, and that comes out to 5 times 12 is 60. 1/2 of 60 is 30, and this was in inches, and it's inches squared. So this side right here is an area of 30 inches squared. Let's use the red color to do this other one. Something that you can do to solve this would be, okay, so guess what? You can't do this side of the shape right now. The reason for that is because in order for you to do the area, you need to know the length of this base right here. And the only way to find that is to use a special theorem about triangles, which we are not covering in this topic. So here's what I want you to do. I want you to just scribble this whole side of this triangle out, and bam, look at that. We found the area of the other one. So like, that's progress, right? All right, so very cool. We're gonna move on. We're gonna talk now about the area of a trapezoid, okay? So for trapezoids, right? A trapezoid, if we roll back up to our notes from before, a trapezoid is a quadrilateral, but it's not a parallelogram. So it has its own formula to do the area. So let's roll back down here. The formula, what color am I on? Orange? We'll use orange. The area of a trapezoid is 1/2 times the height times the sum of both the bases. Okay, so you have to get that formula, kind of either write it down or try to start memorizing that, right? So all you really have to remember is that the area is 1/2 the height times the first base plus the second base. Okay, so remember, we have to do this inside part first in the parentheses, right? So let's fill in what we know. It's going to be 1/2, that's there already. The height we know is 5, and then in parentheses you have 4 plus 9. Okay, we can do the units later, it's okay. So let's start simplifying, right? This is still 1/2 times 5 times something. What's 9 plus 4? It's 13. So now we need to do 5 times 13, which is 65. And then we need to cut that in half, which is going to give me 32.5. Now, once you get to this final answer, you have to make sure that you go back and worry about the units. Otherwise, your answer might be wrong, okay? So this was all done in centimeters. And because it's area, it's a 2-dimensional measurement. So we're going to put an exponent of 2, or centimeters squared. So the area of this trapezoid is 32.5 centimeters squared. This would be a great place for you to pause the video and work on this other trapezoid that we have here, calculating that area and see if you get the area correct. Okay, so to do this area, it'll be 1/2 times the height, which is 10, times the addition of the two bases, so 8 plus 6. Okay, so that's area equals 1/2 times 10 times 14. 8 plus 6 makes 14. Area is 1/2 times 140. 10 times 14 is 140. And then half of 140 is going to be 70. Now we're done with the calculation part. We just need to make sure that we get the units, which is centimeters squared. It's in centimeters and it's a two-dimensional measurement by base and height, so that has to be squared. Okay, and I think this is actually the last problem. Yeah, this is the last kind of problem that you might see in this topic, which is about composite shapes. So a composite shape is one big shape that is made up of several smaller shapes. And so you might look at this right here, right, and say, there's no way I can find, you know, the area of this whole thing. There's no formula. What formula do I follow? Okay. But really, if you break this shape apart into two pieces, right, you have a triangle over here, which you have a formula for, and you also have a rectangle over here, which you have a formula for, base times height, right? So we can absolutely find the area of this entire figure. So let's do blue for the rectangle. And let's try and look at just the rectangle, right? So just the rectangle part here would be 6, 5, has to be 6 down here, and then 5. This 14 describes this entire length. But right now we only care about this part, which is part of the rectangle, which has to be, in order for it to be a rectangle, these have to be congruent, which would be 6 and 6. So how do you find the area of this shape? It's just base times height, so 6 times 5, which is 30, and it's centimeters squared because it was in centimeters and it's an area. Okay, so let's go ahead and we will do the next part. We'll do it in orange, why not? We need to find some information here, right? So are these two lines directly across from each other and touching the top and the bottom here, the bottom base and the top base at the same place? Yeah. So if this one's 5 centimeters, this is, ooh, that's not what I'm drawing. This one's also 5 centimeters. So in this triangle where there's a right angle formed right here, we have the height. And all we really need to figure out here is the base. Okay, so let's think back, right? This entire length is 14, okay? But the part that is the rectangle, we figured out, was 6 centimeters. So what has to be the rest of this to make 14 altogether? It would be 14 minus 6, which is 8. So to find the area of this triangle, right, you have right angle, that is 5 centimeters, and this is 8 centimeters. We follow our area formula, which is 1/2 of the base times the height. Well, 8 times 5 is 40, so half of 40 would be 20, and therefore this is 20 centimeters squared. Now remember, we asked for the area of the whole thing, which will be the rectangle plus the triangle. So all together now, we'll use, I guess, red for this. The area, ooh, that's, again, not drawing, it's a shape. I'm just messing up with all of this. The area in total is 30 plus 20, which is 50 centimeters squared. And that's it. You've got the area of the entire shape. That's what composite shape area problems are all about. You got to break the big shape down into the smaller shapes that you have a formula for and solve it. Okay, let's do one that's a little more difficult, and then the last one, I'll let you, it'll be like a challenge question, and then I'll come back and show you. So let's take a peek at this one. It looks like we have a trapezoid, right? So we have a trapezoid because these two pieces, the bottom base and the top base, are parallel, but the sides, the left and right side here, they're not parallel with each other. That's why this is a trapezoid, okay? We have an area formula for trapezoids, right? But in order for us to, like, there's two ways to do this, really. You can find the area of this triangle right here. You can find the area of this triangle right here and the area of this square in the middle, and you can combine them all, okay? That's one way, but you have to find 3 different areas for that. An easier way would just be to follow the trapezoid formula, which is 1/2 of the height times the bottom base plus the top base, okay? So in this method that I'm showing you, all right, there's really only one piece of information that we're missing, and that is, what is the measurement of the entire base of this trapezoid? We have this piece, which is 5.5, and this piece, which is 8.2. What's the middle piece? Well, if these are parallel from each other, then this also has to be 7.6 meters. So all of these measurements added together will give us the whole base. I need a calculator for this because I'm really bad at adding decimals. 8.2, and I get 21.3 meters for that base. I have enough now to go ahead and do my formula. This is the height, this is base 2, and this is base 1, so let's plug them in. The area is going to be 1/2 of the height times the 2 bases added together, which is 21.3 plus 7.6. So we have 1/2, 8.6. Oh, I don't know why I wrote an equals there. Sorry, my bad. That's not supposed to be there. We need to add 21.3 plus 7.6, and that is multiplied by 28.9. So let's do the multiplication next. That would be 8.6 times 28.9. And then we need to cut that in half. So this would be 1/2 times 248, 54. And then area will be half of that, which is 124.27. Okay, so that's an oddly specific problem. It has decimal points. We'll just roll with it. It's cool. What are we missing? Pause, reflect, think about this problem. What didn't I write here? I didn't write the units. So the units are meters, and because we're talking about area, which is 2-dimensional, that would be meters squared. The area of this shape is 124.27 meters squared. Okay, last problem. Challenge problem. Pause your video, take a look at this shape, okay, what's it made up of, and see if you can find the area of the entire figure, okay, area of the entire figure. Okay, to find the area of the entire figure, all right, we're making an assumption that these two sides are the same. So 3 plus something has to give me 7, because the whole thing is 7, right? Actually, I'm not even making an assumption, because if this side and this side are the same, the other two sides must also be the same. That's how a square works. So 3 plus something, we'll call it x inches, has to be 7. So 3 plus x is 7. What is the number? It's 4. So this is 4 inches, okay? Now, what if I asked you for the area of this? Well, that's pretty simple because it's just a square, so it's base times height. It's 7 times 7, which is 49. But what if I asked you just for the area of the shaded section at the top here? Pause the video, think a little bit. What do you think you could do to find just this shaded part? I don't care about this part. I just want to know the area of this part. So if you said that you would find the area of this triangle and subtract it from the area of the whole square, you'd be right, okay? You know how much area the whole square is, and you can find the area of this triangle. And if you literally, if this was drawn on a piece of paper and you took a pair of scissors, right, and you cut across this diagonal line and cut that triangle off, then you'd have only the shaded area left, and you need to find how much area that takes up. you would be removing this triangle from the square, okay? So we're going to take the area of what we know, which is 1/2 the base times the height. Let's use blue for that. The area of this triangle, okay, this bottom part, right? This is 4 inches and this is 7 inches. The area is 1/2 of the base times the height. Area is 1/2 of 7 times 4 is 28. Area equals 1/2 of, oh, never mind, we already did that. Half of 28 gives me 14. And that's the area of this triangle, which is 14 inches squared. Okay, all right, let's recap. The area of the entire thing, the whole square, okay, area of the square is equal to 49 inches squared. The area of that triangle at the bottom is 14 inches squared. So what's 49? And you cut off that 14 inches squared that triangle takes up, okay? What's 49 minus 15? Okay, the area here is 35 inches squared. And that's it. If you added these two areas together, you should get 49, and the area of this whole thing is 7 times 7, which is 49. Okay, so that's it for this lesson. Like last week, I started to assign you guys some delta math. So I want you to go ahead and go to delta math now and practice some of the problems that we have. It's going to be questions about like perimeter and area, and also these composite questions, okay, which are really going to test your knowledge here, all right? Give those a try and then see how you do. Remember, in delta math, there should usually always be an instructional video that you can watch that is right there with the problem that will kind of walk you through how to do the problem the way they're asking it to you. And then also, if you get the question wrong, or if you click like the give up button, what it will do is Delta Math will actually give you like a detailed explanation of how they arrive at the correct answer. And you can kind of read that solution and follow along and see maybe where, just where you might have made a mistake in your thinking or something. So give that a try, and then if you have not already passed this part of Essential Ed, this is level M Math, M as in Michael. That's level M Math. I'm sorry, I lied. This is level E. This is the end of level E. My bad. This is level E, and this is lesson 4 in level E, which is about shapes, area, and perimeter. Thank you so much, guys, for tuning in tonight, and I really hope that this lesson made sense to you. If it didn't make sense, or if something is just not clicking, please feel free to send me a message, and I will go into Google Meet with you, and we will figure it out together, all right? Thank you, guys. Have a good night. Bye-bye.